All right, listen up, you people. We got some people off in the little B room. We got some other people registering for something. Okay, so absolute and conditional conversion. So if it converges absolutely, then it must converge also. Okay, this goes back to all thumbs are fingers, but not all fingers are thumbs. Just because it converges doesn't mean it absolutely converges. But if it absolutely converges, it must converge. Yes. All lions are mammals, but not all mammals are lions.
Everything in this world is either a potato or not a potato.
Yes.
What if it's not a potato?
Depends on the gender of the potato.
Oh my god.
Okay, so. Alright, so I was kind of waiting for you to show back up. So, alright, so definition, absolute convergence. So, a series is absolutely convergent if the series, absolute of each one, is convergent. So the absolute value of each one is going to be convergent. If the series is absolutely convergent, no, don't do that.
No. Not today.
If the series is absolutely convergent, then it's just regular convergent also. So if it's absolutely, it's both absolute and regular. So it's possible for it to be convergent, but not absolutely convergent. And I believe we have one. I think I threw one of those in the notes to show you what it would look like. All right. So determine whether the series here converges. Now, first we have to figure this out. So I need to make a sum of something. Wow, that is super loud.
Can you hear that on the recording?
Yeah. If you watch the videos, you might have known that. So, what? So you're saying 2 to the k minus 1? No. No?
We're gonna wait on that.
No, come on, you guys. I want you guys really. This is like one of those puzzles that you guys got to try and. You have a huge noodle, okay? Use your noodle.
Because it works for everyone else.
Which one?
The first one. This one becomes 0.
Okay, so I'll give you a hint. This is a geometric series. Okay, so what are we going to have? Anyone? So what am I going to have here? This is going to be a geometric series. So what do you think this one is?
So 1 squared. 1 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. So 2k.
2 to the power.
Yeah.
So you're saying 2 to the k
Yes. Minus 1.
Okay.
1 over.
1 over 2.
So this one doesn't work out because I'm not going to get my fractions, am I?
Yeah, 1 over.
Okay, so now let's change that now. So, So now you're going to say it's going to be 1 over 2 to the, make it a little bit easier for you. Is this one going to work? So whenever you're doing these, you have the series right here. Put it down on paper and try out each one. Try out each one to make sure that it's going to work out. And especially if you get 1 here. I know that when if it's something to the 0 power, I should have 1, right? That's going to help me out. So that's where I can get my k minus 1 out of this, right? Yes?
Yep.
Okay, so now in this case right here, this is a geometric series. In a geometric series, I have to start by looking at the r value. What is the r value here? R is 1/2. R is 1/2. So remember, if R was less than 1, right? Remember, between 0 and 1, okay, it's going to do what? Converge. And if R is greater than 1, it's going to diverge. Do you guys remember that now?
Yeah.
Okay, so now from right here. So now because I have this, I now could look at it and say, oh, hey, this right here, I'm going to compare it to a this right here, a geometric, so I get this, and because of this, I know I'm going to have an alternating here, right? Yes? And okay, so now I'm also going to have right here, it's going to be times -1 to the
It'd just be k.
Oh, yeah.
-1 to the k, right?
okay, but think about it. Think about it. What's the sign of my first one?
Positive.
Positive. So if it's 1 here, wouldn't this whole thing be negative? It'd be k minus 1, right? That'd be k minus 1, wouldn't it? So that's going to help me match up my signs all the way. Could you please take off the glasses so it looks like you're like sleeping? Yes, thank you. Because yesterday I was like worried that you were sleeping because you had like drool on your paper, but you were just that excited about the math. All right, so with this one right here, I know that this is going to converge. Okay, because I'm going to get this thing right here. So the absolute convergent test of each one of these, I know this, my R value is 1/2. So this is going to be convergent.
Wait, but it's positive, negative, negative.
You're right, because remember we're looking at the absolute value, so
Wait, how does the alternation work? That's positive,
Yeah,
negative, negative. It shouldn't go positive, negative, positive, negative. It goes positive, negative, negative, positive.
we're
It goes 1/8 minus 1/16 minus 1/32.
okay. So what is my one issue here then? Remember when we were talking about this the other day? We were talking about like the first couple might not be part of that. Remember when we were trying to sandwich them in between a minimum, maximum, right in there, the upper bound, lower bound. And so this, that 1, or the 1/2 is going to be outside of that. So absolute value, so as I keep going with this, right here to get that pattern, you're right, it is negative, negative. I didn't notice that earlier. Crap, okay. Negative, negative, right here.
So it's a negative, positive, negative, positive.
Okay. So there is a pattern on it. No, it actually doesn't change my work at all, though. Do you know why it doesn't change the work? Because it's going to be absolute value. I'm checking for the absolute value of this. So as this right here, if you notice the numbers, I'm only looking at those, right? So the absolute value of this, if that is going to converge by itself, so therefore it's going to converge absolutely. So because the absolute value, it is going to converge absolutely, so therefore it's also just convergent. So this is going to absolutely converge. You know what's funny? I did my notes twice and didn't notice that the pattern was negative, negative, plus. That's horrible. Anyway. All right. So let's try this one here. Determine whether the series converges. So now I'm going to do a comparison test. Let's do a comparison test. So I'm going to compare it to something that I know is going to converge. Can I factor something out of that I know is going to converge? One over what?
K squared.
Yeah. So I'm going to compare this 1 over k squared, and absolutely one over k squared right here, I know must converge, right? I know that's a must. So that has to converge. And so for this, I'm going to do that this is going to end up, the absolute value of each one of these is also going to converge. Because as I'm doing my pattern, what's going to happen here? I'm going to go absolute value, absolute value, absolute value. Okay. Now, I'm going to show you guys what this is actually doing. So the sum of these, so as they keep going, it's going to converge to a certain point. So, where's my calculator? Oh, there it is. And control, divide, sine, it's in radian. Where k, in this case right here, x, starts off at 1, right? Starts off at 1, and then goes to that way. So I'm only going to be plugging in numbers from here to infinity. So I'm not dealing with any of this asymptote or any of this mess right here or anything over here. I'm only going to be dealing from here on. So those numbers are going to converge, aren't they? So absolutely, if it's going to be convergent, so now let's take a look at the one I'm comparing it to. Because if I give you guys regular numbers, that seems to help out a lot. Right there. So I'm comparing it to this. So when I'm doing this, I know that it's going to end up becoming the same thing down over here at the very end, isn't it? Because that sign, remember how the sign alternates. It goes up to +1, and it goes down to -1, right? So that is going to alternate up and down. Even though it's going to be absolute value, that means that every time when it's negative, it's going to be flipped and go back up, right? So it's going to stay above the line, so it's not going to go into those negatives. That's going to be above the x-axis there, and it's going to stay there. So I'm comparing it to 1 over x, or in this case 1 over k squared, right? Now, that one is also going to do the same thing. As I keep going towards infinity, as it keeps going on all the way, this one is actually going to converge, right? Because as the bottom number goes to infinity, that goes to 0, right? Yes? And since it's doing the exact same thing with the sign over the k squared, it's going to do this exact same thing. It's just, for this, it's always going to end up becoming the same thing. So since I am comparing it to something right here that is going to be convergent, and it's going to be less than or equal to, because it's going to be doing the same thing. So this is going to be an absolute value off of it, so it's going to keep going on this one right here. So eventually, as this thing keeps going, we know that this has to be convergent, because this is convergent. Because that's part of this that's going to converge, and then the sign would be just an alternating, so it has to converge. It's noisy out there. Did I make sense, or did I confuse you guys more? Part of this, factored out, is going to be convergent. I look at that piece is going to be convergent. My piece of sine is just going to go up and down, but I want only absolute value of that. So this is also going to absolute converge. All right. If a series is absolutely convergent, then it is convergent. But just because a series converges doesn't mean it absolutely convergent. Conditional convergent. A series that is convergent without being absolutely convergent is called conditionally convergent. Hold on one second. All right, so determine whether a series is absolutely or conditionally convergent. Okay, determine numbers p for which the series is absolutely convergent. So this is an alternating series, right? So I need you guys trying to do a noodle dance here. So I should try and figure out where it would be divergent, where it would be convergent. So I want everyone trying to noodle this one out right now, because this is a nice puzzle. You're thinking of values of p for this to be convergent, divergent, and conditionally convergent, yes. going to give you a hint. There's 3 places. Let's try and get the easiest one out of the way. When is this going to diverge?
When P is less than 1.
P is less than? Not going to say 1.
Less than or equal to.
It's not 1. Here's a hint. It will go to infinity. It would go to infinity. What would it be? What would make this go to infinity?
Any negative number?
Any negative number, right? Would make it go to infinity, right? So if it's a negative number, so that means that P would have to be what? So P would be less than 0. So this would diverge. So if P is less than what? Less than 0. P is less than 0, it's going to diverge. Okay, let's go with the absolute now. So the absolute one should be easy. Should be easier now that I have this piece picked out. So now that we thought about that,
P is greater than 1.
P greater than 1, right? So if P is greater than 1, this would absolutely now, what if it is 1? If it's equal to 1, it would be conditionally. Why? What is 1 over n? It's harmonic, right? 1 over n would be the harmonic, wouldn't it? So that would be the harmonic. So that one would not work out all the time, right? So somewhere in between there. So we're going to say from 0, because it's not equal to over here, to where? To 1. It's going to be conditionally. So conditionally convergent. So it could converge depending on what I have here. So that's going to be conditionally convergent. So it's not going to be an absolute convergent. That one's going to be a conditional convergent. Now, if you guys remember way back when we were doing the tests, what was the test? When I take the limit and it have to go to what? Limit would go to what? It would go to 0, right? As we're taking the limit to infinity, it goes to 0, so that was one of my tests, right? Okay, so when I do 0, if P was 0, P was 0, that would be just 1 over 1, which is 1. Okay, so it at 0, it wouldn't work out very well. And if it was 1, it would be harmonic in there. So in between there, it would be conditional. So depending on whatever else I have in there. Okay? So when you're looking at stuff like this, you need to look at the individual parts. What's going to make it go to infinity? What's going to make it go to 0? If it goes to 0, that's what I'm looking for my convergent or divergent. Okay? Infinity and 0. We're not going beyond. Crap, it's almost time. All right. Ooh, yes. I got you a nice little graph here. Absolute convergent tests. So from right here, if it's going to diverge, it's always going to diverge. If it's going to converge, okay, we could just say converge, right? But now we're also going to be testing for absolute. So if this converges, it's absolutely. If this diverges, it's going to be conditionally convergent. Does that make sense now? Nice graph, little bubbles. Yeah. Did I blow your mind on this? But hopefully, I thought this was like really good.
Yeah, that makes more sense.
Okay. Original series is absolute convergent and diverges. Okay. There. I got all the notes in there for you. So all the properties and all this other stuff to go along with it.
Extra
Okay.
slides.
I know I accidentally did. I'm sorry. But maybe you want to write some notes or something.